Hi everyone, the focus of this video is to build an XGBoost model using Snowpark ML end-to-end. My name is Sika Das and I'm a senior architect on the machine learning field CTO team. We'll first begin with a brief overview on what Snowpark ML is, and then we'll show you a demo to go through what a full end-to-end pipeline will look like. First, we offer a Snowpark ML modeling API for model development. So this allows you to use popular frameworks for feature engineering and training directly in Snowpark. And it helps you scale out your feature engineering and machine learning training pipelines as well. The pre-processing functions improve performance and scalability with distributed execution for common scikit-learn pre-processing functions. And the model training functions really allow you to simplify model training for these scikit-learn and XGBoost models. The second focus area is around Snowpark ML's machine learning operations offerings, which includes a model registry API for model management and deployment. So this includes deployment and management of models such as coming from Snowpark ML, PyTorch, TensorFlow for deep learning, open source LLMs from Hugging Face, and so on and so forth. Our goal is really to make models useful. Our model registry is a secure, scalable model storage backed by Snowflake Stage, and it also enables versioning of models with flexible metadata and metrics in Snowflake tables. Finally, it provides a standardized packaging and integrated development into the Snowflake warehouses, as well as into Snowpark container services, really eliminating the need for manual UDF or stored procedure creation. And moreover, it also seamlessly integrates with Snowpark ML development, and models are native objects within Snowflake, thus enhancing their integration and usability. So in order to demonstrate these capabilities, I'll walk through a scenario to predict the price of diamonds given different qualitative and quantitative attributes. I'll show you how to build an end-to-end XGBoost model using Snowpark ML. So first, we'll clean and ingest the diamonds dataset into a Snowflake table from an external stage. Second, we will apply feature transformations and build a pre-processing pipeline. Then we'll create a training data frame with this pipeline. Third, we'll apply grid search to train multiple XGBoost regression models with different hyperparameters and select the best model. Then we will log the best model, deploy it, and create an inference data frame with the same pre-processing pipeline and perform inference on it. We'll finally write the predictions back to Snowflake and then create a Streamlit app in Snowflake to help users decide whether the diamond they're shopping for is fairly priced or not. So let's get started. In this first notebook, we will walk through the data ingestion portion. So we will read in the input data from an external stage, do some data cleaning on top, and then write the final clean data to a Snowflake table. Okay, so first, we'll import some of the needed libraries. We're importing Snowpark, as well as some data science libraries like NumPy here. Next, we will create the Snowflake connection, and you can see the connection has been established. Now we will use the Snowpark data frame reader in order to read in this diamonds data set from the external stage. And so we can see here that it has been read in, and we can take a look at a quick view of what the table looks like, as well as some descriptive stats about it. Now we can go ahead and do some data cleaning. So first, we're going to force the headers of our columns to uppercase using Snowpark data frame operations, really just to standardize so that the columns are all standard when they're written into a Snowflake table later on. Then we'll do some standardization of category formatting for one of our columns called cut, just to make sure they're all uppercase and there's no spaces in between, so it'll be easier to process later on. Finally, we'll do some casting of decimal types to double type, just for precision purposes, again, to make our life easier later down the line. And then we'll write the clean data to a Snowflake table. Now let's switch over to the second notebook. So in this notebook, we will walk through a few transformations that are included in the Snowpark ML pre-processing API, and we'll also build a pre-processing pipeline to be used in our third notebook when we go through the ML modeling portion. So to begin, again, we import all of the necessary libraries, Snowpark, all the different pre-processing functions from the Snowpark ML library, as well as some metrics like correlation, which will also compute, and include some additional data science libraries here, pandas, NumPy, and matplotlib, and seaborn for visualization. So let's go ahead and get those imports in. And again, we will establish a connection to Snowflake as before. So now we can basically input the data that we had cleaned up in that first notebook. And so I'm just reading it into a Snowpark data frame here. And then the very first transformation we'll do here is a min-max scaler to go ahead and normalize our caret column. And so you can see here, caret norm, it's been normalized. Second, we will use the ordinal encoder function within Snowpark ML in order to take the color and clarity columns and convert them from categorical to numeric so they are more meaningful and have some sort of ascending order to them. So finally, just to illustrate, we can also do one-hot encoding. And so in this case, I'm taking all of our categorical columns, the color and clarity, and one-hot encoding them. So you can see they've been outputted. So there's a column for each of the categories, and it's been encoded with either a 0 or 1. So now we're finally ready to build out a full pre-processing pipeline. I've laid out kind of all the categorical columns and all the categories associated with each of the columns here. And now I define the pipeline here and apply it to my initial data set here. So as you can see, all of my pre-processing has been done. All the additional columns have been now added. And I can go ahead and also save this pipeline object if I want to use it later down the line or for a different project as well. So I just save it to one of my stages here. Now that we have done all of our feature transformations, we can go ahead and do a little bit of data exploration. So we can go ahead and see what features are correlated with each other. And so we can use Snowpark ML's correlation function to better understand the relationships. And we can also visualize it, so it's much easier to understand. So we can see that caret and price here are very highly correlated, which makes sense. So we can even look at them a little bit closer. And we do see a pretty strong relationship there. So let's move on to the third notebook now, the final part. So in this notebook, we're going to train our XGBoost model using all of the feature transformations that we did before. And then we're also going to show you how to deploy the model and perform model inference with it. So as before, I'm importing all the necessary libraries. Here, I'm actually importing XGBoost from Snowpark ML, as well as grid search. So we'll do some hyperparameter tuning with it. And then I'm also importing the model registry for deployment. Let's go ahead and establish the connection to Snowflake again and load in our input data. So as before, now I'm applying that pre-processing pipeline that I built earlier. And I'm applying it to my training and test data sets. So after I split my data sets, I can now use that same pipeline object to transform both. So that's done. And now I can illustrate, how easy it is to build a quick model. So here I'm building an XGBoost regression model, fitting it to my training data set, and then just showing kind of what the predictions look like. And here we go. So we see a predicted price has been added. And we can even analyze the results using Snowpark ML's mean absolute percentage error function. So now we have our price, our actual price and our predicted price, and we have a mean absolute percentage error calculated between the two. So we can also go ahead and visualize the results by plotting it. And we see a pretty good correlation between the actual and predicted price. So our model did a pretty decent job of predicting price here. But let's take it a step further and use Snowpark ML's grid search CV function to find our most optimal model here based on the optimal set of parameters. So we can pass in a set of different number of estimators, as well as a set of different learning rates, and see which combination gives us the best mean absolute percentage error value, which is how we're analyzing the accuracy of this model. And setting up this function is fairly straightforward as well. We just pass in the estimator here. We want to make sure we're using all the threads in our node. And then we just pass in all of the input columns, as well as our label, which here is price, and then what our output column should be named as. And then we just run the fit and wait for it to give us the optimal model. So this will take about 2.5 minutes to run. So now it's ready. We can take a look and see what our best estimator is. So as we can see, the parameter of an estimator is being 500 and the learning rate being 0.4 gives us the most optimal model for us here. We can also visualize the grid search results just to see how varying the learning rate and the number of estimators varies our MAPE values as well. And so continuing on, same as before, we can take a look to see how our predicted price versus our actual price looks like using our optimal model, and then look at a plot of the two as well and see how the correlation looks now. So as we see now, our mean absolute percentage error has improved a bit as compared to before. So we're good to go now, and visually it's looking good as well. So let's go ahead and now deploy our model. So before we do that, let's save some important metadata first. So some of the different hyperparameters, as well as the accuracy metric, the mean absolute percentage error. So we can log this along with our model. And once we have that, we can create our model registry object to log our model, and then pass in our evaluation metric as a part of the metadata that will be logged as well. Finally, let's confirm that it was added correctly. And yes, I see my model here, and I see the various metadata associated with it, as well as the metric that we tagged here. So now we're ready to deploy. So we use the model registry's deploy function to deploy the model that we logged above. And let's just confirm it got deployed. Yes, it did. It shows up when we look at our list deployments function here. And now we're ready to use this deploy model to perform inference. So again, I call my model registry object here based on what I named my model and my model version. And then I can directly use the predict function from the model registry object in order to run my prediction on my test data frame. And as you can see, my predicted price got added to my test data frame, and now we're ready to do some cleanup as well. So that's the end of this portion of the demo. Now I'll pass it along to Chase Romano to show you how to build a Streamlit app in Snowflake.
Hey everyone, I'm Chase Romano, Solutions Architect at Snowflake, and today I'm going to show you how easy it is to create a Streamlit app. And we're going to leverage Sika's model to build a Streamlit app that's going to help us predict the price of a diamond based on a few parameters. So in Snowflake, we now have Streamlit in Snowflake. So you can click on the Streamlit button, and then we'll just create new Streamlit app. And here I'll just call this like test app. You'll choose a database, choose a schema and a warehouse, and click create. When you create a new Streamlit app, you'll actually be given sample code on just a very simple Streamlit app that you'll see run on the right-hand side. So when working in Streamlit and Snowflake, you'll have your code on the left, you'll have the app on the right, and you'll see we have the interactivity that Streamlit gives us. You'll notice that in order to create your session in Streamlit and Snowflake, you'll just use get active session, and it's this easy to start a Streamlit application. There's no need for external IDEs, no need for pip installing. We manage all of the packages for you up here in the package icon. Say I wanted to add a package like Altair. I can simply search for it, check Altair, come back out, and now I have Altair loaded and ready to go. Let's say that 5.0.1 is not the version of the package that I would like to use. I can simply hit the drop down and pick a different version and be on my way to creating a Streamlit app. So that's how easy it is to create an app. Now, what about sharing it? This is what the Streamlit app will look like to the end user. And I can simply share it with any role in my org by clicking a role at my Snowflake organization. And then anyone with that role will now be able to see the Streamlit application while hiding the backend code. I can simply click this copy link and share it with anyone that has this specific role. Now onto the app that we're going to have for the diamonds data set. So in the diamonds data set, we simply have an application that lets us input the parameters from Sika's model. It'll do the transformations, the pre-processing, and then feed it into a Python UDF. We now have everything ready to go. And I can simply change fair to ideal, and we would expect this to increase the price of our diamond, and you see that it does. And so now that I have Sika's model ready to go, I can create a Streamlit application that leverages that model so that the users have a front-end way of interacting with models that the data scientists have built. I can go back, change it to very good, and this will decrease my price. And you can see that this happens in near real time. And all that's happening in the back end is we're executing the user-defined function that Sika created in her machine learning model. Thank you for coming today. And we recommend that you go check out our quick starts and check out the one for today's session called Intro to Machine Learning with Snowpark ML for Python that will have all of the sample code from today's presentation. Thank you.
Hi, in this demo, we're going to see how we can create a dynamic dataset in Honeydew, then deploy it as a view in Snowflake, use it to train an ML model in Snowflake, and then get some predictions. So I have already prepared our dataset. It has order date, payment method, and revenue, and we are excluding some values here as payment methods that don't have enough samples for training. Let's preview this first to see that we have the right data. Yeah, we do. And now let's deploy this to Snowflake. Okay, so now we can go to Snowflake. Let's see that we have the data here. And let's train the model. Yeah, the model is trained, and now let's get some forecasts. And voila, we have some forecasts on our data.